Let's get started right away. Let's start with lesson 17. I want you to know all the complete solutions are on the syllabus at the top, so you can look and I have the whole thing planned out for you. So that's just a tip. You can look on there first before you even ask on the help board. So let's get started. You're going to be able to see my palette thing here. So the first one was lesson 17. Letter C. Okay, so this is just 3 lines that are intersecting. 1, 2, 3, something like this. We have some things that are filled in. We have 20x plus, you can barely fit it in there, 5y degrees. We have 40 degrees. And we have 2x plus 5y degrees. We have 110 degrees, and that's it. Now we have 2 variables, so we're going to need 2 equations. We can find some other angles by just vertical angles are congruent, so we know that this angle is also 40 degrees, and these 2 angles are congruent, so we would know this one is 2x plus 5y degrees. So let's just see what we can do. We have to write 2 equations. We know 20x plus 5y is equal to 110 because these are vertical angles and vertical angles are congruent. So we're going to write 20x plus 5y equals 110. And we don't have any other vertical angles that we can set equal, but we know that these 3 angles have to add up to 180 degrees. So I'm going to do that below. I'm going to set them equal to 180 degrees. 40 plus 110, because they lie in the same on a straight line and a straight angle is 180 degrees, plus 2x plus 5y equals 180. And we're going to get 2x plus 5y, and if we subtract, this is going to be 150 from 80, we're going to get 30. So I'm going to just plop that underneath this one, and it's 2 variables with 2 equations, so we can just use elimination. It looks pretty simple, right? I'm going to multiply by -1 through here. We're going to get 18x equals 80. Yes, it doesn't come out evenly. It's okay. So we're going to get x equals 80 over 18 and definitely reduce that to 40 over 9. And then you have to put it back in, take this and put it back into one of these 2 equations. You can put it back in here for x. And when you do that, you're going to get y equals 38 over 9. I'm going to not do every step. Some of these things you should be able to do on your own. Okay, the next one is number 9. Number 9 is a distance problem that you can always rewatch this if I erase anything too soon or go too fast. Number 9 is a distance problem without the word. So we can think of this as rate m time m plus rate w time w equals 250. I call this the mother equation. It's the one all the other equations are going to go into. Rm, they tell us, is 50. Rw, they tell us, is 80. And then they give us this one. This is going to stand for t, time, and another time equals 5. One of these variables is going to need to stay in the equation. You have to have one variable in. So I'm going to choose he gets to stay in the equation. So I'm going to solve this one for t sub m, and I get 5 minus t sub w. So we're just going to plug everything into the mother equation. So Rm is 50. Tm is going to be this. So it's going to be 5 minus tw. Rw is 8. Tw is the variable that's going to stay, equals 250. Once you plug it all in there, you're gonna multiply it through, and you're gonna get 250 minus 50 tw equals plus 8 tw equals 250. Combine your TWs And I'm going to subtract the 250 to the other side. Oops, there's already a 250 over there, so we're going to get 0. And whatever this is, it's going to be, this should be 80. I think it got erased, or I didn't write it right. Let me just double check that. Yeah, this is 80 right here. So this is going to be 80. This is going to be 80. So you're going to get 30 TW equals 0. So TW, if you divide by 30, is going to equal 0. And then you can go get TM by just putting TW in here. So you get TM equals 5 minus 0, which is 5. And that's all there is to that one. Okay, the next one's a similar one. It's problem number 11. So 2 different people put these on here. So let's just erase that. We're going to do problem number 11. Same idea, probably just a tiny bit more complicated. R sub m, t sub m equals r sub r, t sub r. Different kind of distance problem, just a note for the future, which we're going to do distance problems this week. R sub r equals 2, and 5 minus t sub m equals t sub r. Actually, this one isn't any harder. It's already solved for the variable. You're just going to go back into your original equation, plug in. So rm is 8. Tm is the one that's going to stay in the equation because tr is solved in terms of tm. So tm, you have to keep one variable in. R sub r is 2. T sub r is 5 minus t sub m. And now we're down to one equation, one variable, so it's very solvable. And we're going to get, I'm going to add that, so we're going to get 10 t sub m equals 10, and we're going to get t sub m equals 1. And then we can get t sub r by bringing this right up here, plugging it in there. And so we're going to get t sub r equals 4. All right, let's do the next one. It would be lesson 17, number 17. So this one is, you're supposed to find the equation of a line. For some reason, this is one that everyone seems to hate. So I'm going to do it real quick here. I have this little bit of a time constraint that I wasn't expecting today. So this is on, the line goes through at this point 1. We're looking for places where the line goes through. A grid line or the axes is even better. So these are just 2 points that I identified on my line. So you want to go through and identify 2 points that either cross on a grid line or through an axis. Like a grid line would be these. Like, so if it's something like on, like right through here, that's a point you would pick. All right, but we don't have that point, do we now? Okay, so we need to find 2 things in order to write an equation of a line. You write your equation, y equals mx plus b. This is your slope-intercept form, where m stands for the slope and b stands for the place it crosses the y-axis. So because these land right on the axes, we can just count our slope. So it's going to rise 2. Here's our rising 2. And it's going to run -1. So our slope is going to be -2, -2. Rise 2, run 1. Or you could go from this point, you would say, run -1 and down 2. So yeah, so the rise, this would be rise -2, run 1. So then our y-intercept is right there. It's -2, if I can see that correctly. -2, so we just plug those in. This is our b. It's where it crosses the y-axis. The slope is your rise over run, so you plug those in. So you get y equals -2x minus 2. The end. Not so bad. Okay, moving onward. Oh, the next one, there's also another line on here. I can't see it really in my book, but it's going down 1, 2, 3, 4. So there's another line. It's vertical. Remember, if it's vertical, it's going to be x equals. It's crossing the x-axis, so that makes sense, right? So the second part of this one is x, which is also 2 v's for vertical, equals 4. Okay, next one is number 29. 29. So we're getting -3 minus 2 plus -4 plus. This one is, if you missed this one, it's probably just because you made some careless mistake here or there. but it's always good to try one of these every so often, right? Okay, here we go. Sometimes you just can't find your error when you look over and over at it. Okay, so we're going to start inside of the parentheses. So I'm going to get negative, and this is going to be -5. And this is going to be -8. Now, right here, you cannot bring a number to a negative powers, but we can bring the whole thing up and make it, so we have this negative and a positive hitting right there, so we're going to make that negative, oops, -2 cubed, and that's going to be minus, and then -2 to the -3rd power. Again, we need to bring it down to the bottom, and this is going to be -2 cubed, positive. Okay, I'm trying to show all the steps here, so let's keep going. So we're going to get 5 -8 -8 minus, and it's going to end up being -1/8 in the denominator. And then we can just continue to clean it up. If we were going to add all these, this would be -16 plus 5 would be -11. These would make a positive, so it's going to be +1/8. And then we're just going to subtract 1/8 from -11, and it will be -10 7/8, or you can make it improper. So that is it for lesson 17. I'm going to try to get one more lesson in on this video, and then I'll do a separate one for the next video. All right, so now we're on lesson 18, and we're going to hit number 12 is our first one. 1812. So it's going to look like this: 7xyz plus 1/xyz. Okay, this is an expression, which means you can't get rid of your denominator because it doesn't have an equal sign. It'll change the value of it. So all you have to do is find your common denominator here, which is xyz, and you try to make this denominator look like this denominator, so you would have to take it times xyz, and that means you need to take the numerator times xyz. This is kind of a strange problem. So you get 7x squared y squared z squared, and then this one, the denominators are the same, plus 1. And that is it for that one. All right, that was an interesting problem. Okay, next one is I missed number 8, so let's go back up and do number 8. Number 8 is divide 5x cubed minus 1 by x minus 2. Okay, long division problem, you need to add your 0x's so that you have every exponent value represented. So it's going to be 5x cubed plus 0x squared plus 0x minus 1 divided by x minus 2. So quickly, so we get 5x squared, because 5x squared times x is 5x cubed, minus 10x squared. We are going to change our signs and add. So we're going to get 10x squared. We're going to bring down a 0x, and we're going to get plus 10x right here. And we would get 10x squared. I'm going to run out of room, minus 20x. Change your sign. I know it's babyish, but it really helps me. 20x minus 1. We go one more time. It's going to just be plus 20 because 20 times x is 20x. 20x, and it's going to be minus 40. And we change our signs one more time, and we add, and we're going to end up with 39. So we put that at the top, 39 over x minus 2. And that is it for number 8. All right, I went fast, I know. I have to be somewhere at 3:30, and it's 3:02. So we have 2 more in this lesson, and then I'll do another video for the rest. So I hope you got that down. You can stop the video and watch it, so I don't need to wait. Okay, so number 14. Use the Pythagorean theorem. Okay, So you have this triangle, it's an isosceles triangle. It has two sides the same. If you have an isosceles triangle where two sides are the same, if you have a perpendicular bisector that comes down the center of it, it will divide the base into two equal segments. So it's saying this is the same as this is the same as this, and this is perpendicular. So if this side is 6, this big side is 10, this is going to be 5, and then we can use a Pythagorean theorem to solve for the height. So here we go. The side squared plus the side squared equals the hypotenuse squared. So h squared plus 5 squared equals 36, equals 6 squared. I don't want to rush that for you. 6 squared. And then we're going to get h squared plus 25 equals 36. And then we could subtract 25 from 36 and get 11. And so the height is going to be the square root of 11. Then we still have to find the area of the triangle. So area of a triangle is 1/2. I have a little delay on my pen because I'm on the internet. Base times height. So we are going to plug those in. So it's going to be 1/2. The area equals 1/2. The base is 10. The height is the square root of 11. 2 goes into 10 5 times. And so your final answer is area equals 5 root 11. You have to have units on this or I will take a point off on your test. Some of you miss a lot of points just because you don't put units on it. And it's units squared. Okay, and we are on our last problem, number 22. Okay, this is a fun one. All right, number 22 is a sector problem. They're a little bit tricky. So what we have here is we have 120 degree angle. I'm going to make that a little bit bigger than 90. And then we have a little angle in here. And we have like this dotted line that's kind of making it look like it's a sector. All right, something like that. I didn't do that too well. Okay, they're saying that this line right here is 15 feet. And that this whole angle from here to here is 120 degrees. We have to find the area of that. If you think of this as a part of a circle, it helps you do the problem. So I'm going to do my circle. There's my circle. And this is, if you think of it as just being a piece of your circle. So I have right here, I'm just going to do my little angle inside of this circle. So I'm going to make it out here like this, over here like this, and the radius is this line that they're drawing right here. It's 15. So the radius is going to be 15. So what we're going to do is we're going to figure out, we know a circle's 360 degrees, and the sector is 120 out of 360 degrees. So it's going to be 1/3 of the circle. So if we find the area of the entire circle and multiply it by 1/3, because it's only 120 degrees out of the full circle, we will have our answer. So let's do that real quick. So the area of the circle is pi r squared. So that's going to be 15 times 15 is 225 pi. And then we are going to take that times 1/3. So we can multiply all these out. So to find the sector, we're just going to take this times 1/3, and you can just pop this in your calculator. So 225 times 3.14 equals, and I'm just going to divide it by 3, and we get 235.5. And then again, it's area, so it has to be units squared, and it's going to be feet squared. All right, so that's the first 2 lessons. I will make a video for the second 2 a little bit later. I'm sorry I'm so late. So stay tuned for the other video.